This is lesson 6.3, solve multi-step inequalities. You should be on page 369. When you solve, or the steps for solving two-step and multi-step inequalities can be applied to linear inequalities. If you want to review two-step and multi-step inequalities, you can go back to lessons 3.2 and 3.3, and that's where we taught two-step equations and multi-step equations. I think watching the video you'll see what I'm doing and remember those steps. Now, when you are solving inequalities, don't forget, this is a big one, and I tried to make a big point of this on the last video and in the last homework. You have to reverse the inequality symbol anytime you are multiplying or dividing by a negative number. Don't forget that. It still applies in this lesson. So let's do a few examples. So if you go to the bottom here, let's try a few of these. Solve the inequality, graph your solution. So this would be a perfect example of a two-step problem. Let me draw up my onion. X is the center, then the times 2, the minus 5 is the outside layer. So I'm going to add 5 to each side, which gives me 2x less than equal 28. I'll divide each side by 2, which gives me x is less than or equal to 14. And now I got to graph it, x less than equal 14. So you notice on my graph paper I made a scale of tens because this scale didn't work. I put a closed circle at 14, and I'm shading everything that's less than equal to that, so I'm going left. There's that example. That's a good two-step example. Here is another two-step example. Let me draw my onion. Y is the center, the minus 6 is the next layer, plus 5 is the outside layer. Start off by subtracting that 5 from each side to get rid of the plus 5. Next, divide by negative 6. Now when you divide by negative 6, don't forget, maybe I should highlight this. Do you notice how my inequality symbol changed when I divided by the negative? It went from less than equal to greater than equal. The negative 6 is on the left cancel. Negative 21 divided by negative 6. That's 3.5, okay? I got to graph y greater than equal 3.5. So I have a closed circle at 3.5, and I'm shading right of that. Let's do one more. This would be another two-step problem. First of all, let me draw my onion. P is the center. The minus 12 would be next. It's inside parentheses. The times negative 1/4 is outside the parentheses. So let's get rid of that times negative quarter first. I'll divide by negative quarter to get rid of that. Now notice, when I wrote this, do you notice how, because I'm dividing by the negative, my inequality symbol was reversed again? I can't forget that, what I have in pink, or I'm going to screw up my answer. Okay, now to get rid of the minus 12, add 12. P less than 20 would be the solution. So let's graph it now. Go to graph paper. You see I changed my scale to fit 20 on here. I put an open circle at 20, and I want the values less than, so I'm shading left. I think that's a good review of solving two-step inequalities. Let's talk about solving multi-step inequalities. Now, multi-step inequalities we learned in lesson 3.4, so that's why I have 3.4 listed there. So when you solve a multi-step inequality, the first thing to look at is, okay, can you simplify either side? And I can't. Do I have variables on each side? Because if you do, the first thing I told you to do back in lesson 3.4 is get all the variables on one side. To get rid of positive 2x, I'm taking it away. Now, if you do that first, the reason I told you to do that first is now you have a simple two-step problem to solve. Look at this. I can draw my onion up now, and this should be very simple for you to solve. Add 7 first, divide by 4. You're finding out x is greater than 6. and that agrees with this. Now, they ask you to graph it. They actually graphed it right here in the book. You can see open circle at 6, shading right. Now, when you solve inequalities, if an inequality is equivalent to an inequality that is true, like -3 less than 0, then the solutions of the inequality are all real numbers. Let me underline that. If an inequality is equivalent to an inequality that is false, such as 4 less than -1, then the inequality has no solution. So what this paragraph is telling you, it's saying that it's possible to have all real numbers be a solution. In other words, anything works to make the inequality true, or you could also have no solution when you solve an inequality. Now, you remember when we solved equations back in Chapter 3, it was possible that you'd get one answer, or you could get all real numbers be a solution, or you could have no solution. It's kind of the same thing when you solve an inequality. We could get a solution set for an answer like we did in this last problem, or we could get any number being a solution, or we could get no solution. Now, the graph of all real numbers would be taking a number line and just shading the whole number line in it, showing that everything would work. The graph of an inequality that has no solution would be a number line with nothing graphed on it. Just a blank number line would show no solutions. Let's actually try a few of those just to make sure you can see how that can happen. So let's try. Here's the first. Let's solve this inequality if we can and graph it. Well, 5x minus 12 is less than or equal to 3x minus 4. I can't simplify either side, but I notice variables on each side. So let's immediately get the variables on one side. Take away 3x first. 2x minus 12 is less than or equal to -4. Okay, now let me quickly draw up my onion. I got to get rid of minus 12, so add 12 to each side. So 2x is less than or equal to 8. Divide by 2 on each side, cancel the 2's out, x is less than or equal to 4. I have to graph that. So I'm going to put a closed circle at 4 and shade left. I don't know that I actually put that on the video. I think you know how to graph x less than or equal to 4 now. Okay, let's go to number 5. Let's solve this and graph it. Well, 5m plus 5 parentheses m plus 5, I have to distribute. I got to simplify first, so that turns into 5m plus 25 less than 5m plus 17. Oh, I got variables on each side. I don't want that. Let's get the 5m and cancel it here. Well, do you notice when I subtract 5m over here and I do it here, all the variables disappeared. That means something's up. That means we're either going to have all real numbers as a solution or no solution. Well, let's see what we got here. We have 25 less than 17. That's false. That's not a true statement. 25 less than 17 is false. That means this particular problem has no solution. In other words, there is no number that I can plug in for m that will make the left side less than the right side. So there would be an example of no solution. Now, if I wanted to graph that on my number line, I keep my number line blank. I don't touch it. That would be the graph for this. Let's go to the next one. Let's try this. Again, I got to simplify on the right side of the problem, so you can see I'm distributing. Oh, I notice I have s's on each side of the problem. I don't want minus 8s on the right, so let's add 8s to each side. And you notice when I do that, minus 8s plus 8s cancel. Well, the same thing happens over here. My variables disappear. That means something's up. That means I'm either going to have a no solution or all real numbers. Well, let's see what's left. I have 1 less than equal 4. Is that true? Is 1 less than or equal to 4? Is it one of the two? Because or means either or. Yes, this is true. 1 is less than 4. So this would be all real numbers as a solution. So when I graph that, on my number line, you can see it was kind of sloppy here. Let me do it again. I'm just drawing that, hey, everything on this number line in both directions with arrows at the end, everything is a solution for that problem. let's do a story problem and we can finish the video, because yeah, we should be able to set up a story problem and solve a multiple step story problem too that sets up. So camp cost, you are saving money for a summer camp that cost $1,800. You have saved $500 so far, and you have 14 more weeks to save the total amount. So that's what I'm writing here. I have $500 plus I have more savings to do. What are the average possible amounts of money that you can save per week in order to have a total of at least, you see that word at least, $1,800. So I want my $500 plus my extra savings to be more than or equal to $1,800. Now, we can't just leave this as more savings. Do you notice it says we have 14 more weeks to save, and we're going to save an average amount of money each of those weeks. So what I could write for more savings, I could put maybe 14W, okay? 14 weeks times the amount we save per week would represent the more savings. So there's an inequality. I just got to solve that. So if I think onion right now, I got to get rid of 500 first, so I'll take away the 500. Then I'll divide by the 14. And since this is money, I should round to the penny. 1,300 divided by 14 is 92.86. I need to save at least 92.86 a week in order to save my $1,800 or more. Okay? I'm going to pause the video there. If you have questions, make sure you ask during class time.